I'm Anil Kumar. Welcome to my series on matrices. We will now talk about combination of linear transformations. So we'll consider clockwise rotation about origin by 90 degrees, reflection of the line y equals to minus x, and combination of the above. So let's try to understand what are these transformations. The first one here is just to rotate an object about origin by 90 degrees. That means if you have an object here in this location, if we rotate it counterclockwise, means like this, 90 degrees, then it will be somewhere in quadrant 2, kind of like this. You see that? So that is 90 degrees counterclockwise, correct? Now the second part of this is to reflect it on the line y equals to minus x. So the second type of transformation which we are going to talk about is to reflect the object on the line y equals to minus x, means that the line is diagonally but going downwards, correct? That is your line y equals to x. Now in this case, if I have an object here, right, so it kind of reflects on this and it could be seen somewhere there, right? So same distance away, right? So it could be reflected and could be seen on this side. So that is the kind of reflection which is reflection on the line y equals to minus x. And then what we are going to do is do the combination of both of them. We'll also understand that this combination is different if we change the order. That is to say, if I call this as transformation A, this as transformation B, then the transformation A to B is not equal to B after A, right? So you could think like this. So it all depends on what is the sequence being followed. So now let's get into the details and understand these transformations and how they work in combination. So the very first one here is to talk about counterclockwise rotation about origin by 90 degrees. So our method has been very simple to work with these matrices. We know that this 2 by 2 matrix does all the trick, correct? And what we need to look into is just unit vectors. Right? We just need to look into the unit vectors I and j to get the transformations. So we'll always consider unit vector I and unit vector j. Then it becomes very simple, since using these vectors we know what AC and BD could be. Now when I say that we are going to rotate about origin by 90 degrees, and now let me take this unit vector I along the x-axis and j along the y-axis, then I could write this as 1, 0, correct? That is my unit vector. Now if I perform this rotation of counterclockwise by 90 degrees, what really happens? Well, in that case, this unit vector will be represented on this side. And it will become what? It will become 0 and 1, correct? So that is the kind of transformation which is taking place, right? So as far as the I cap is concerned, the unit vector I in the direction of this is concerned. This transformation counterclockwise by 90 degrees will make 1, 0 the I cap into 0, 1. So A and C becomes 0 and 1 for us. Is that clear? Now let's look into J. What happens to J? Well, in case of J, if I do this counterclockwise rotation, it will come in this position. And here, the value is what? The x value here is -1 and the y value is 0. So that coordinate makes B and D as -1 and 0. So this transformation matrix, we'll call this as A, will do counterclockwise 90 degrees rotation for any coordinate point x and y in R2. Got it? So if you do that, what will you get? You will get x as 0, 1 times x plus y coordinate will be -1 and 0. So basically, that is the matrix A which will do this transformation. Correct? Is that clear to you? So that is so simple as that, once you understand these concepts. Perfect. So we'll call this as our matrix A, which can do counterclockwise around the origin. Now here is a reminder for you. When we talk about rotational matrix, right? Let me write rotational transformations. Then we actually use cos theta minus sine theta cos theta as our rotational transformation matrix, right? So that is also correct. You will note that if angle is 90 degrees, right? So for 90 degrees, cos of 90 degrees is 1, cos of 90 degrees 0, sine of 90 degrees is 1, and so if you place the values, you will get exactly the same matrix, correct? So many times we generally use rotational transformation as cos theta minus sine theta cos theta. Well, that helps if the angle is something else, right? Maybe 45 degrees, we can always place those values and get the result. But when it is 90 degrees and so on, we prefer to use these numbers, as many students may not be very familiar with the trigonometry part of it. Okay, so I hope that is absolutely clear. So we found our first transformation matrix A, which is 0, -1, 1, 0. Okay, so let's move on and look into the second transformation, which is reflection on the line y equals to -x. So now we're talking about a reflection on a line which is diagonally crossing the coordinates, correct? Now if you look into this line, and again we look into the points which for us are the I cap, which is 1 and 0, so it gets reflected, so it will be here on this point, right? So this becomes minus y value is -1, the x value becomes 0. So that is basically 0 minus 1. And therefore, the transformation will be 0 minus 1. You get the idea. So it is as simple as that. Do you see that? What happens to the j? Now this is our j cap, which is 0, 1. Now when you reflect this on this line, you get a point here, which will be what? So here, the x value is -1, the y value is 0. So you get -1, 0. You get the idea. So that becomes the transformation matrix. Does make sense to you? So we'll call this as our matrix B to perform the transformation. You get the idea, right? So it is 0, 0, diagonally, and -1, -1. That is what it is. And that does the trick of transforming, which is the reflection on the line, y equals to -x. We could at times also write this as I should write x plus y equals to 0, because we always write in standard form x first, right? So I hope that makes sense, right? So that is kind of important. So we have done these two, and we have understood how they could be done individually, right? So we have seen what are the transformation matrices for doing counterclockwise 90 degrees and also separately reflection on the line. Now let us try to think about the combination, right? So here we are doing a combination which is what? Okay, let me make a smaller one here now. We know all this. So which has two. Counterclockwise about origin. So we take this point here. We do counterclockwise about origin. And then we reflect it on the line y equals to minus x. And then we reflect it on this line to get the point there. So that is the transformation which we are doing. Right? Now, how do we get this counterclockwise plus the reflection using what we have already got so far? Okay, so for counterclockwise, we got the transformation, which was what? So moving from this to this place for I, we got, let's rewrite. So it is here in this position, it is 1 and 0. And in this position, it was 0 and 1. So we got 0 and 1, right? Now for a point which was here, I'm talking only about not the reflection this time, but for J, we're talking about the counterclockwise. Is that okay? So this position is minus 1 and 0, right? So minus 1 and 0 was A for us. Now what was B for us? As far as B is concerned, we reflected this here, right? So at this point, it was the x value 0, y value minus 1, and so it was 0 and minus 1. On the other hand, when we reflected this to this point, it was same as minus 1, 0. It came to the same point, right? So these are the two transformations which we have just learned. This is for counterclockwise rotation and by 90 degrees, and this one is reflection on the line. Correct? Now what we want to do, we first want to do counterclockwise and then the reflection. Correct? So this is what we are trying to do. Okay, so let's use a different thing. So this is what we are trying to do. Counterclockwise followed by the reflection, right? So that means we do this part first, right? So basically, we get this part first, which is 0, minus 1, 1, 0. And then we do the other part, which is 0, minus 1, minus 1, 0. So what we really work with is B and on A, right? B on A. That is what we're doing. Correct? This is what it means. So when you first do this inside A, and then you do that. So what is the total overall effect of all this? Well, we can just multiply these two 2 by 2 matrices and get our result. So we get 0 times 0, which is 0, and then we multiply this minus 1 by this, and we get minus 1. So we get minus 1 here, right? And then if we do with the second row, 0 times minus 1 is 0, and minus 1 times this is 0. So we get 0 here. With the second row multiplying with the first column here, that gives you 0, and this also gives you 0. And now with the second row, minus and minus gives you plus 1. So we get plus 1 here. So that becomes the overall effect of this particular transformation. You get the idea. So BA becomes a transformation matrix. Correct? So that is how we are going to get the transformation matrix for a combination. You get an idea, right? So once you do the individuals, then you could work like this. So it is minus 1, 0, 0, minus 1, that kind of a matrix. Now what does that really signify? It signifies that as far as the x value is concerned, that value 1, 0 will get to minus 1 and 0, right? So this value will come to -1 and 0, that is right here, and the y value will be at 0 and 1. So basically that remains here itself. So what are we seeing? We are seeing a reflection on the y-axis, correct? So if this is the y-axis, this is the x-axis, then what does it show? It shows a reflection on the y-axis. Is that clear to you, right? So this combination really shows that that point will come on this side, 1 on the y-intercept will remain right there. So it is basically a reflection on the y-axis. Does it make sense to you? So that combination gives you reflection on the y-axis, correct? Now let's see what happens when we interchange the combination. That is to say, if I perform reflection first and then the rotation, then what happens, correct? So let's look into this part. So what we are trying to do now here is that we had the two matrices. Let me write down both these matrices. Let's get back to our paper and then we'll write it down. So A was, so this time we are beginning, first we are doing reflection, which is B, which is 0, -1 and -1, 0, right? And then we are doing A, and A is 0, -1 and 1, 0. Is that okay? So that is what we are doing. So here, first we are doing B and then we are doing A. Okay, so let's write it down. So first we are doing B and over B we are doing A. That is what the sequence is. So basically, this operation is being performed and over that the other operation is being performed, right? So first we'll do B, which is 0, -1, -1, 0, and then we'll do A, which is 0, -1, 1, 0. Does it make sense to you? So now what we get here is, let's do it. So when you multiply this row with the first column, 0, 0, and that gives you +1, right? That gives you +1 here. And this with the second column will give you what? So 0 gives you 0 and 1 gives you 0. You get 0 here. Now, with this row and the first column, we are looking for something here. 0 and 0 will give us 0. And with this thing and that, 1 and -1 gives you -1. So that's what we get, correct? So now, what is this signifying? This is signifying that a position which is here for x, which is at 1, 0, remains here, right? 1, 0. As far as the other point is concerned, y point, which was originally at 0 and 1, has moved to this part. Do you see that? Which now becomes 0, -1. So that is a reflection on the x-axis, right? So this is reflection on the x-axis. So earlier it was a reflection on the y-axis. This time it is a reflection on the x-axis. So if you interchange the operation, you get totally different result. So I hope that makes sense. So we also saw here that the transformation A over B is not really equal to the transformation B following A, right? So when you interchange it, you may get a very different result. So I hope that helps you to understand the whole topic. So we have seen in these set of videos basic transformations using 2 by 2 matrix. These are all linear transformations, right? The origin remains right there. All the straight lines get into straight lines. Perfect. And it is just a scale factor and reflections about the origin most of the time. Correct? So that is what we are looking into. Now, we have also seen that if we have the combinations, the multiplication of matrix works for us to get the transformation matrix of the combined effect as seen in this particular video. So I hope that really helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.